Hi, hello, welcome to Dr. Zahir Math. In this GSMA 102 calculus series, in this video, I'm going to do module 3, exercise 8.3, hyperbolic functions. You already studied this hyperbolic functions in calculus 1, which is sine hx, cosine hx, tan hx, cosecant hx, secant hx, and tan hx. Sorry, not tan, cotan. So cotan hyperbolic functions. All these things you studied already in the calculus 1. So now we are going to study the integration for these functions. Before going to this, let me relate both the normal trigonometric functions and the hyperbolic functions also. Right. So what is the integral of sine x? You already studied. Integral of sine x is what? Negative cosine x plus c. Right. And what is the integral of sine hyperbolic function? Let me use another color. Integral of sine hyperbolic function dx is only cosine hyperbolic x plus c. Look at here. There is a minus here and there is no minus here. So it is plus. Okay. Right. So let's go to the next one. Integral. After that sine, we studied cosine x dx. So what is cosine x dx? Which is sine x we studied plus integrating constant c. Let me write all these things. Then I'll come back to the hyperbolic functions. Then integral secant square x dx. What is that? I told you differentiation and integrations are brothers. They are opposite to each other. So tan x derivative is what? Secant square x. Secant square x integration is what? Tan x plus integrating constant c. Right? Yes. Now the next integration is integral cosecant square x dx. So what is the derivative of cot x minus cosecant square x? So what is the integration of cosecant square x minus cot x plus integrating constant c? Right. What is the derivative of secant x? Secant x tan x. What is the integral of secant x tan x dx? Which is equal to secant x plus c. Right. The last one is what? Cosecant x. What is the derivative of cosecant x? Minus cosecant x cot x. So what is the integral of cosecant x cot x dx, which is equal to minus cosecant x plus c. Now let's go with hyperbolic functions. What is the integral of cos hyperbolic x dx, which is just sine hyperbolic x plus integrating constant c. Look here, there is a plus and there is a minus. But here both are plus. This is one point you need to remember. Actually, when you see the 6 formulas, 4 formulas are same. Only 2 will be different. Keep in your mind. How many rules are same? 4 rules are same. Only 2 are different. Let me tell you what are the 2, which one is different, right? Okay. Next is integral secant h square. After h, you have to put square, okay? Secant h square x dx. Secant h square x dx is equal to tan hx plus c. Same. Okay. Integral cosecant h square x dx. Integral secant hx tan hx dx. Integral cosecant hx cot hx dx. Okay, right. What is the formula for cosecant square? The same formula, minus cot hx plus c. Secant, there is a small changes here. Okay, keep in your mind. And there is a small change here. Only these 2 I said. Here you will get minus secant hx plus c. Okay, right. And this is going to become same minus cosecant hx plus c. So which are the 2 formulas are different? These 2 formulas are different from the normal formulas. Here it is negative, here it is positive. And here it is positive and here it is negative. Can you see that? So here it is positive and here it is negative. So here it is negative and here it is positive. Okay, right. So only 2 rules are different. Keep in your mind, only 2 rules are different. What are they? Secant hx tan x and sine hx integration. Okay, right. So keep in your mind, these formulas you have to memorize. Teacher, what about the remaining integration formulas, which is tan, which is cot and all these things? Not necessary. Just a direct conversion you remember in hyperbolic functions. What do you mean by direct conversions? Derivative to integral, integral to derivative formula. Let's go to the first question. Evaluate integral x square sine hyperbolic x cube dx. Here 2 functions are there which is in product. So we need to think about what? Substitution method. Okay, right. Let's go to substitution method. Right, which one you are going to call it as u? The best way is what? This is the one giving trouble. So I'm going to put x cube is equal to what? U. So put u is equal to x cube. What is the next step? Du by dx, which is equal to what? 3x square. Cross multiply, du is equal to 3x square dx. Look at the question and try to convert everything in terms of what? U. That is the main idea of what? Substitution method. Right. So we have x square and dx. Sorry. We have x square and dx. Sorry, again we have x square and dx. This will be converted. There is x square, there is a dx. So divide by 3 and divide by 3. So what you will get? Du divided by 3 equals x square dx. Okay, finish. And what is the value you are going to put it for x cube? And this will be equal to what? U. So finally, the integral will be converted into x square dx. You are converting into du divided by 3. And this is going to become what? Sine hyperbolic u. Right. So 1 by 3 will come out, integral sine hyperbolic u into du. So 1 by 3, what is integration of sine hyperbolic u? Just now we told you the rule, which is cos hyperbolic u plus integrating constant c. This is going to become your answer. Clear? No. Which one? This is not going to become answer. You are going to put what? U is equal to. What is the substitution we have taken? U is equal to x cube. So we are going to put U is equal to x cube. So 1 by 3 cosine hyperbolic x cube plus integrating constant c. So this is going to become your final answer. Clear all of you? Yes. So U is the one we gave the substitution. So we didn't stop it. You did not stop. Sorry. You shouldn't stop it with U. You have to replace it by what? The original variable. Let's go to the next question. Evaluate integral 1 divided by cosine h square. So let's go to the solution, right? Integral 1 divided by cosine h square 3x into dx. We know that 1 by cosine is nothing but what? Which is secant hx, right? So this is integral secant h square 3x into dx. Keep in your mind 3x, it is not x, right? So what is the derivative integral of secant h square? You have to go back to the formula, right? So let me go back to the formula. Secant h square, this is the formula for secant h square, which is what? Tan hx. Okay, right. So let me write the formula over here, right? So the formula is integral secant h square x is equal to tan hx plus integrating constant c. But now we don't have x, we have 3x. I told you in the previous exercise, whenever the angle is multiplied, so you need to divide it in the integral rule. So just keep it in your mind. So what happened to this one? This is equal to tan hyperbolic 3x and divided by 3. Why? Because the derivative of 3x is what? 3. And in integration, you should divide by 3 plus integrating constant c. So this is going to become your answer. Okay, right. Let's go to the next question. I don't know how many questions are there. Yes, 3 or 4 questions, right? Evaluate integral tan hyperbolic 3x. The same idea is coming out. So first of all, let me write the formula, right? What is the formula for integral secant hx and tan hx, which is equal to what? Minus. I told you there is a minus. Secant hx. So let me show you the formula again. Just have a look on this. Yes. Look here, there is a minus. So secant hx tan hx is going to become what? Minus secant hx. Okay, right. So now what is the situation over here? The situation is here tan hyperbolic 3x and secant hyperbolic 3x, which is equal to minus secant hyperbolic 3x. If it is x, you stop it because it's divided by 1. But secant means 3x means you have to divide by 3. So this is going to become your final answer. So easy, but you have to remember what? The rule. Okay. I'm sorry, integrating constant, you have to add plus c. Let me check the previous one added or not. Yes. Okay, now let's go to the last question. They are asking the area which you studied in module 2, right? So interesting questions. Let me start. So area, you already studied it, right? What is the formula for area? Area is equal to integral f of x dx, a to b, right? You need the limits for x. Okay, right. So let me start to find the limits. Okay, so you put y equal to 0 in the equation. What is that? Y is equal to sine hyperbolic x 3x. So if I put y equal to 0, I'll get sine hyperbolic 3x. So you take in the calculator or whatever it is, you're going to put it as what? X. So 3x or 0, so it's going to become what? 0. So x is equal to what? 0. Sine hyperbolic 0 is 0. Okay, right. So you're going to get already x equals 1 is there, and the question is find the area, right? So this equals integral x equals 0 to 1, right? Sine hyperbolic 3x times dx. So what is the integration of sine hyperbolic? We studied sine is cosine. There is no minus. So plus cosine hyperbolic 3x. One thing you need to do, don't forget divide by 3 because it's 3x. And the limits are what? 0 to 1. So this equals 1 over 3 will come out. Upper limit substitution, cos hyperbolic 3 multiply by 1 minus cos hyperbolic 3 multiply by 0. Upper limit minus lower limit, which is equal to 1 by 3 cos hyperbolic 3 minus cos hyperbolic, this is 0. Cos hyperbolic 0 and cos 0 is going to become what? 1. If you want, you can simplify this also by what? Calculator, right? So this finishes your 8.3 exercise. So thank you so much for watching. If you found this video helpful, please like, share and subscribe to support the channel. Don't forget to hit the bell icon so you get notified when new videos drop. Comment below if you want me to cover other topics or have questions. Until next time, keep practicing and stay confident. Okay. See you. Take care. Bye bye.